on. We're on. Well, maybe. Oh, excuse me. Welcome YouTube beauty people. Assuming that's all we got so far. Yep. Well, we'll wait a minute for we'll start strolling in. We got some things to do today with sequences, some weird ones, some important ones. And yeah. We're going to talk about link I sent you guys, Tower of Hanoi, and yeah, talk about that game, how it works, and we'll talk about sequences, what kind of sequence this makes. We'll figure out how to calculate the pattern so we can figure out any number of blocks. And yeah, so welcome. It's Thursday. This is Algebra 2 YouTube live stream. It's 2 p.m. and yeah, hello. New people going in the chat. Hopefully you guys all played this Tower of Hanoi game, and I need to actually make it in the chat. You'd love to see my dog? Well, the dog just rang. We put a bell by the door. The dog just rang the bell, which means the dog is going to go to the bathroom. So soon, the dog will come back, and we'll have the dog on the screen. So soon, we will have the dog on. So hopefully you guys. Oh, so soon, we will have the dog on. So hopefully you guys. Oh, I appreciate that. Sorry, she's needy. Yeah, poops everywhere. Okay, here is the link. Needy. Hopefully you guys got a chance to play around with that. And yes, hopefully you play it well. I don't know if it's on Cool Games, but it's on here. Okay, so we're going to start talking about this thing. I want to first set up on the whiteboard a table, and we'll talk about the table as it relates to the game. All right, so one side of the table we're going to have discs. I don't think discs is a K. What do they call it in the website? That's the discs with a K. Yeah. No. Discs. The number of discs on that side, and then on the other side we will have number of moves to complete the table. I need to complete the puzzle. So, puzzle is like this thing. Hopefully you went here. Our goal is to move all of these things in our tower. This just looks like a silly, like 2-year-old kid's game. Over to this third table here. So it's this. And we're going to do it in as few moves as possible. So 7 moves. And there's one rule. We cannot put bigger shapes on top of smaller shapes. So this will not go on top of this one. Okay? So maybe that's not the best move, so we're going to restart. So we want to do it in as few moves as possible. We can't put things back on top of each other. So I know this is this is a 3 disc, but we're going to start with a 1 disc. So if we go back to our table, if we have 1, we want to move it to the other side of the table. That just takes 1, or to the other side of the towers. So we have 3 towers where the discs can go. We have 1 disc. We just need to move it to the third one. Right? If we have 2 discs, we're going to play the 2 disc game using the 3 disc thing because this doesn't go lower than 3. Okay. Oh, sorry. This doesn't go lower than 3. Alright, so we're just going to pretend this purple disc isn't here. So it would take 1 move, 2 moves, 3 moves. So if I have 2 discs, I have 3 moves. Okay, and then they said 3 discs was 7. Let's try that. So how can we get the discs all the way over? Did anybody do this? That's what I really want to know. Anybody do this? Anybody do this? I'm guessing not, but that's okay. That's not a problem. We'll go through how to do it. And it matters where you move this first disc a lot. This way. Okay? I'm going to solve it where it takes more than 7 moves. If I move this here, right, and then this thing here, it's 2, and then 3. Well, and then I gotta move this purple one. Can't go there. That's for here. And then I gotta get this thing off of that. So, well, let's move this here. It's here. It's here, and we're already up to way more than 7, right? And then this would go there. 9, 10. Look, it's 11 moves. Now we want to get to 7. 7 is the lowest number. You can do it in a lot more, right? So it matters where we move this first one. It matters where we put this middle one. So I'm going to put this here, and this here, and this on here, and this on here, and there, and there, and then we did it in 7. Okay? So we moved them all over. It took us 7 moves, and larger discs can't go on top of smaller discs. Hey, puppy. You're just going to chill right there, maybe? No. Okay, so 7. And then we can go up, and we got a pattern. 15. So on our table, 4 moves takes 15. The difference here was 2, and then it was 4, and then it was 8. What do we think 5 is going to be? 2 and 4, then 8 is our change. Well, if we go up to 5 discs, it takes 31 moves, which is a difference of 16. I know it's 31 because the game says, oh, you can't see what it says 30. The screen's in the way. Well, that's real annoying. It says 31. You'll just have to believe me. And if we go up to 6, then it's 63. Which is 32 more. So our table looks like this. And we're adding, every time we go up a number, we're adding a square. Right? Or, there's another way to think about this. How do we get from this number to this number? Well, these numbers are really close to something. This is pretty close to 1. This is pretty close to 2 squared. This is pretty close to 4 squared. Pretty close to 3 squared. Right? Pretty close to 5 squared? 8 squared? Maybe? Okay, so we have n, and we're looking for an equation here. What happens when we do n squared? We get not the right. It'd be 1 and 4. And then it I don't remember. Sorry, 9. But these are also really close to 2 to the n numbers. Like if I do 2 to the 0, 2 squared, 2 to the third, so I get 1, or I get 1 here. This would be 2, 4, 8, 16. Well, I think our equation is 2 to the n minus 1. It's 1 less. So this is the number of moves per tower command. On these things. Now, today, hopefully you got a chance to play that tower game. The more discs you have, it gets to be a lot of moves, right? This is 63 times we got to move those little discs. In class, we would have actually done it. We would have gotten it physically. But today we're just going to look at weird patterns in numbers that are useful, that relate to things, and that's it. We're not going to have any like practice problems or anything. You're close, Andrew. X squared minus 1. It's close to x squared minus 1. It's 2 to the n. So 2 to the x minus 1. We're multiplying 2 over and over and over. It's doubling every time, the number of moves doubles, but it's 1 less than doubling. So when we did 2 moves here, right, when we have 2 discs, it takes 3 moves. If we double the number of discs, right, 2 squared, 4, it's 1 less move than that. But then if we double that, if we double this number, or if we double this number, it's 1. Or if we double this number, it's 1. That's another way to think about it. Multiply the number before times 2 and add 1, which would be pretty close to the. So we could write that as a regression thing, right? Like we did on Tuesday. So we did. To find our new number, you take the previous number, multiply it by 2, and add 1. Double it. So to find our 5th thing, you take the 4th number, you double it, double 15. So this is our recursion formula. Or rule. I'm running out of whiteboard. You gotta stop shooting on that. There we go. Okay. So that's a cool thing. And that game, here's the game again. We're just moving the discs around, and 6 is a lot. So the key here is going slow. I mean, not going slow, but moving one thing at a time. And this takes a while. We're going to have to rebuild this whole tower, all 3 of these, in the middle so that we can move this 4th. We'll do it. So we're going to do this here, and that up there, and then this one needs to be, here, actually. So that's the wrong way. We need to do this here, here. There, we got to rebuild that tower in the middle. Now we have the base over here. We just got to move these things all onto that base. So this one here. Wait a minute. Nope, not that way. So this. And then we did it in more than 15 bits because I messed up. So this whole thing, this Tower of Hanoi, is a pattern, right? There's another important pattern. We're going to talk about two more things. You can see them up here in line. I think Fibonacci number and Pascal's triangle. And I'm on Wikipedia because I want to show you some pictures that are on Wikipedia. But let's go back to this screen. This is Tower of Hanoi. We're going to erase all that. And we're going to do Pascal's triangle first. Alright, so it's a triangle made up of numbers. The outside edges are all going to be ones. So I'm going to go ones all the way down. We can do one here, one here. Now this number takes the two numbers above it and you add them together. And then you would take these two numbers and you add them together. So 3 and 3, and then this is just a 1. You can imagine that there are zeros. Give us the ones. Oh, we don't need the zeros. Okay. This is the beginning of the triangle. And then we would add these together. We get 6, 4, 4, 1 here, 5, 10, 10, 1. And the triangle is symmetrical, right? It's the same on both sides. It's always going to be, all the way down. And then we would add, so we'd get 20, 15, 15, 6. And this creates some cool patterns. This triangle is, let's go Pascal's triangle. And I wanted to show it to you before the other one because the other one uses part of the triangle. Not off the bat. Okay, so this Pascal's triangle, it goes on forever, so you could keep going. And it's just a cool math thing. It gets used a lot in high-level math. It's been around forever. It's a binomial expansion, so it's got some weird things. The area is related to this little chart right here, which is kind of cool. Might not make sense, but we are multiplying a binomial is two things being added together, right? And so here we're adding them, and we're not squaring them, we're just adding them together. So we have the lengths here. Length 1 plus length 2. When we square them, that gives us the area. So we have a squared, we have b squared, and then we have 2ab's, and that makes the whole square. When we cube them, Misha, what are you doing? Sorry. When we cube them, we get the volume of this box, and here are all the components of it. When we put them to the fourth power, we get some weirdness because now we've moved the box. Okay. And so you get all of this being the volume, kind of the volume of that thing. But that's not really important. It's just a use for Pascal's triangle. It makes it it's the values here. So we have 1, 1, then 1, 2, 1, then 1, 3, 3, 1, and then 1, 4, 6, 4, 1. So that uses Pascal's triangle. There's a really quick way to figure out these multiplications, which is really useful. We're doing a lot of multiplying and sums. Okay, most of this I'm not super worried about. That's going to be higher level than what we're doing here, but yeah. So we want to talk about a different sequence though. Do the Pascal triangle. I'm going to erase it. We're going to erase this thing. Triangle. And we're going to talk about the Fibonacci sequence. This is sometimes called F. Okay. Capital F, sorry. It's the important one. Alright, so the beginning of the sequence is 0 and 1. And I want you to think, I'm going to write these down kind of slowly so you can think. What's the next number? Predict the next number. How do we get the next number? What did I do to find the next number? Next number 1. 2. And then 3. And then 5. 8. 13. 21. 34. And this is going to. So what are we doing here? Well, we're taking our previous two numbers and we add them. And that gives us the new one. Okay, so we have a recursive way to write this. Fibonacci number, whatever it is the previous number plus the number before that. So if we wanted the sixth number, this is 1, 2, 3, 4, 5, 6. The sixth number, if we want to get 5, f of 6 is going to equal f of 5 plus f of 4. And so that would be 3 plus 2. Give me 5, which is the sixth number of the sequence. Okay? And so this only works when n is greater than 1, right? So we're not getting negative numbers here. All right, I'm going to go backwards further than that. But we get some cool things. The areas of the squares all add up to look like this thing. So I know my screen's kind of cutting off the box there. That's an 8. This is an 8 right here. Yeah, this is 8. So we have a 1 box and a 1 box. We have those 2 boxes together. We get a 2. I have to be right back. Sorry, we're just leaving in the middle. So this is kind of small, but we would take the 1 and the 1, we'd add them together, we get 2. The 2 and the 1 together make a 3. And so we get these areas here. That was side links. Okay? And this makes this curve. Oh, it's very tiny. Well, that's annoying. So this curve, and this curve is an important curve. It shows up all over in nature. It's really close. The Fibonacci spiral is really close to the natural number spiral. It's a good approximation. Okay, which we haven't really looked at the natural number spiral, but you probably have seen this before in art and things. This is not that. This thing. So if we rotate the Fibonacci sequence, we get this. This is a flower. So plants use the Fibonacci sequence to rotate. Okay. And this is kind of maybe confusing, but it's pretty, right? So sequences are over math. Here is Pascal's triangle. And then we can find the Fibonacci sequence, these red numbers, by adding up numbers in Pascal's triangle. And the reason it's slanted like this is because we're not just going to add all the numbers in the row. We want to add the numbers that make up the Fibonacci sequence. Oh, I think that's it. Today's kind of a slower. We're not like taking a test for this chapter or anything. The Fibonacci sequence is used all over in math and all sorts of things. It's closely related to the golden ratio, which makes sense. Be seeing any sort of that. The Mandelbrot set, and that kind of thing. This GIF is kind of cool. Just goes on forever. I think that's it for this chapter of sequences. I wanted you to see some interesting ones, some weird ones, some ones that are natural and show things. Wikipedia is an awesome tool for that. Usually, though, the math articles in Wikipedia are way more complicated than what we're doing. So if, like, next year you're in a math class and someone asks you, like, write a report about this, or, like, talk to me about this thing, don't just go look it up on Wikipedia, because you're going to get all the calculus and higher answers that, like, even I am like, I don't understand what that means. Not that I couldn't, but I don't, because I don't know everything. I think that's it for today. Not complicated today. Tomorrow, before we just are done, I'll get the dog on here too. But before I just go, I want to talk about some stuff. The grades, I haven't graded anything from this week. I've got some people messaging me asking about that, and continue to turn stuff in. When you send it to me on email or remind, it doesn't get deleted or go anywhere, so that's a really useful kind of thing. What I was saying, because the parent was confused. Training and work. Yeah, sorry. Continue to turn stuff in. It's in the Dropbox. I'll send another email with that Dropbox info. I'll send an email maybe tomorrow. We're going to do a Zoom call tomorrow. So if you have any questions, that's a good place too. If you have questions, ask me. Also, the chat or send me a reminder, an email. Usually, if I'm like, oh, this is an interesting question, you should probably read my emails first, right? Which no one here maybe, but read my emails. They have information in them. And then, yeah, I'm the YouTube stream thing. We'll see if I continue to do this. The first time we got a lot of people, and now it's not as many people, which is not surprising to me. It's not like I can force you guys to show up and do work, but I'm not sure how valuable it is as a use of my time. So we'll see. I don't know. I kind of need. We'll talk tomorrow, and then I need to think about it over the weekend. If we don't have any questions, I guess I'll go get the dog back inside. She's been kind of silly. And that'll be it. I'm glad they're informative. It's not like we would do nothing. We would do something. I'm just not sure that this format. I do like it. It's just a lot of effort, and I'm not sure. We'll see. I'll be right back. Sleepy puppy. Sleepy puppy. I don't know how long she's gonna last. She doesn't know because of the computer and camera. Shoot thing. Grumpy. Hey, over here. Right here. Oh yeah, look at the camera. There you go. You're interested in that. Hi. Hi. Oh, we don't want to be on. Sleepy puppy. Yeah. Puppy in training doesn't like to be told no. Misha, you're okay. You're okay, Misha. I'm just holding you. It's okay. It's okay. Yes, it's okay. Yeah, Andrew. Yes, I do like that too. That you can go on YouTube and watch the videos. It is useful. And today's lesson isn't like a topic where I want you to do. Oh, this is cool. You should see it. So I don't hate it. It's just we'll see. We'll see. I like that it's on YouTube. I think it's valuable. So I'm not against it. I just want to do the best I can to like help you guys and teach you. So we may need to reevaluate if things aren't being the most effective they could be. What does it matter? What does it matter? Why are you so upset? Okay. Okay. Good man. Where are you going? Yeah. It's good talking to you. I'll see you guys on Zoom tomorrow. I'll send you an email later today with an invite with a link and a time and password. So you'll need a password to log into the Zoom call. Okay? Yeah. And I'll talk to you guys later. See ya.